Morning, everyone. This is the start of our Factorial Notation Part 2 lesson. So we're continuing with the Factorial Notation shell note. We're going to start at example 3 today and continue with 3, 4, and 5. Okay, so the first thing that I want you to take a look at when we look at the examples that we did yesterday, every single one of our factorials were numeric. 10 factorial, numeric factorial, 20 factorial, 105 factorial. All of those are numeric factorials. When we take a look at example 3, what you're going to notice is all of a sudden you have what we call an algebraic factorial. Little bit more difficult. So notice you have the binomial n plus 3 quantity factorial, n minus 2 quantity factorial. Now, in order to deal with the algebraic factorials, you're still going to use your factorial rule, which says n factorial equals n times n minus 1 times n minus 2 times n minus 3, dot, 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 3 times 2 times 1. So nothing has changed. Just because we're doing an algebraic factorial doesn't mean that there's a new rule, doesn't mean that there's a new law. It's still the same factorial rule that we applied with the numeric. Now, the difference is that your n isn't necessarily just a number like 20 or 105 or 97. Your n is the binomial. That's your n value. So hold on, let me talk you through the rule. N, got it. N minus 1, got it. N minus 2, n minus 3, dot, 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 3 times 2 times 1. So notice my n is the binomial, subtracted 1, subtracted 2, subtracted 3, dot, 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 3, 2, 1. Now, some of your brackets need a little bit of tidying up. First one doesn't. Second one does, because 3 minus 1 is 2. Third one does, because 3 minus 2 is 1. The next one does, because 3 minus 3 is nothing. Dot, dot, dot. 3 times 2 times 1. Beautiful form. Everything's perfect. Let's try another one. In the next example, 3b, your n value is n minus 2. It's the whole binomial n minus 2. So let me talk you through it. N minus 1, n minus 2, n minus 3, dot, 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 3 times 2 times 1. So same factorial rule that I was using all along, I'm using in my algebraic examples. So a couple of the brackets need some cleaning up. First one doesn't. Second one does. Negative 2 minus 1. Negative 2 minus 2. Negative 2 minus 3. Dot, dot, dot. 3 times 2 times 1. Beautifully situated. Perfect. Now, can I ask you to just notice something and then we'll talk about it later? Can I get my highlighter out and can you take a look at these numbers in the binomial brackets? 3, 2, 1, nothing. Probably if there was another one sitting there, it would be n minus 1, n minus 2, and so on. Okay. -2, -3, -4, -5. If there was another bracket sitting right there, I think the speculation would be -6, n-6, n-7, and so on. So notice that pattern inside the binomial bracket. Perfect. Can we flip now to example 4, please and thanks. Notice the instruction for example 4 reads simplify. You know that the word simplify means let's clean it up. Let's tidy it up. Okay, well, let's take a look at the numerator in my example A. n+2 factorial. I just learned how to do these algebraic factorials. Let me try it again. n minus 1, n minus 2, n minus 3, ... 3, 2, 1. All over. Let's take a look at the bottom. Again, I just learned how to do these. n minus 1, n minus 2, n minus 3, ... 3 times 2 times 1. Now, both the numerator and the denominator need to be tidied up. Okay? Both the numerator and the denominator need to be tidied up. So let me start in the numerator. First binomial's nice and neat. Second binomial cleans into n+1, 2 subtract 1. Third bracket is just n. Next bracket is n minus 1, ... 3, 2, 1. So all I'm doing is collecting like terms in the brackets. I'm going to do the same thing on the bottom. 1 minus 1 just leaves me with the n. 1 minus 2 leaves me with -1. 1 minus 3 leaves me with -2. 3 times 2 times 1. So you're thinking, geez, Miss Martel, how have I tidied this up, or how have I cleaned this up when it looks bigger and it looks more confusing? Well, can you take a look in the numerator and in the denominator and see if you see sort of like a pattern of repetition? Now, hold on. Let me explain to you what I mean by that. Remember when we first did the 97 factorial over 93, and we wrote it out in long form, and then all of a sudden we noticed that from 93 on, in both the numerator and the denominator, it was a repetitive pattern, and we could cancel it? Same thing that we noticed in the 10 factorial over 7 factorial. Everything from 7 on was a repetitive pattern, and we could cancel it, and it allowed us to simplify. The same thing is happening in these questions. There's a repetitive pattern. It starts at a certain point, and it's going to allow us to cancel. So hold on. I'm hoping you guys notice this. Take a look. And I know the bottom seems to have an extra binomial, but it's there. It's in the numerator as well. I just didn't happen to write it out. So my repetitive pattern begins right at n+1. That means I can cancel all that out. And my simplified final answer for A is n+2. Let's try another one. Let's try B. Okay, hold on. n minus 2 factorial. So again, I'm getting good at this. I gotta go slowly. n minus 1, n minus 2, n minus 3, dot, 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 3 times 2 times 1. N factorial, that's just our basic rule. n minus 1, n minus 2, n minus 3, dot, 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 3, 2, 1. Okay, I'm going to do a little bit of tidying up. So n minus 2 is tidy as it can be, n minus 3, n minus 4, n minus 5, dot, 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 3, 2, 1. I'm going to rewrite the denominator just as it stands. And now I'm going to ask you guys to take a second and see where you see what I like to call the matchy-matchy, the repetitive pattern. Where do you see something on the top matching with something on the bottom? I see it right here. And so on. So what that allows me to do is it allows me to cancel from n minus 2 all the way to the end on both top and bottom. So my answer then to B is going to be 1 over n minus 1. Excellent. Let's take a look at the next one. Slowly but surely, right? We're just trying to get good at this and master the skill. So n plus 1 factorial. n minus 1, n minus 2, n minus 3, dot, 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 3, 2, 1. Okay. n minus 1, n minus 2, n minus 3, dot, 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 3, 2, 1. So for my first step, I just keep repeating the factorial law. Second step, I'm just going to clean up the brackets. So I'm collecting like terms. Positive 1 minus 2, positive 1 minus 3, going to do the same in the denominator. Negative 1 minus 1, negative 1 minus 2, negative 1 minus 3. And for my next step, my cancellation step, I'm actually looking where I start seeing the repeating. So if I see an n minus 1 on the top and an n minus 1 on the bottom, that's where the pattern is starting. So what will my final answer be? N plus 1 times n. Now it's written in bad form this way because we'd prefer the monomial to sit out in front. So in my final step, all I did was switch the monomial out in front and move the binomial next to it. Okay, let's keep going. Weird, that has a 2, a coefficient of 2 out in front. Sort of like the doorman idea. So I'm going to leave that 2 out in front, and then I'm going to evaluate the factorial, because just the m minus 2 is being dealt with by the factorial. So hold on. There's my n minus 1, n minus 2, n minus 3, dot, dot, dot. Sorry guys, I'm running off the paper here. Let me grab a scrap. Dot, 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 3, 2, 1. Let's do the bottom now. N minus 1, n minus 2, n minus 3, dot, 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 3, 2, 1. Again, some nice tidying up needs to occur. Hopefully I don't go off the page this time. Negative 2 minus 1, negative 2 minus 2, negative 2 minus 3, negative 3 minus 1, negative 3 minus 2, negative 3 minus 3, and now I'm going to ask you where you see the repetitive pattern start. Where does the matchy-matchy start? The matchy-matchy starts right here at the m minus 3. So my final answer, my final simplified answer is 2 bracket m minus 2. These are going to take a little bit of time, guys. You're going to have to practice. You're maybe going to have to watch the video a second time because there's a lot of writing. These are definitely going to take some time. Okay, can we take just a quick look at the visual difference between E, F, and G compared to A through D? A through D are all division questions. They all have a numerator and a denominator. Every time you have a numerator and denominator, there's going to be some beautiful matchy-matchy and some beautiful cancellation, just like you've seen in the first 4 examples. For E, F, and G, you're not going to have the same thing. There isn't going to be any cancellation. All you're trying to do is tidy up what you're looking at. So hold on, let me give you an idea. Let's take a look at E. When I look at E, that n plus 4, that's very, very similar to the 2. It's like a doorman. It's standing out in front of the function. It's just going to sit there. The factorial is actually only applying to the n plus 3 binomial. Oops, sorry, my mistake. This should be a 4. So what I'm going to do now is I'm going to run my factorial formula for the n plus 3. n minus 1, n minus 2, n minus 3, dot, 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 3, 2, 1. Okay, I'm going to do a little bit of cleaning up. 3 minus 1, 3 minus 2, 3 minus 3, dot, 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 3, 2, 1. Again, we're in a situation where I'm asking you to simplify, but all we've done is made the question bigger and more complicated. Not really. Take a look at our numbers. They're going down beautifully. They're going down beautifully by a consecutive natural number. So if I wanted to simplify, why couldn't I just rewrite this whole question as n plus 4 factorial? Because if I asked you to expand this, you would rewrite the previous line. So the simplified answer to the original E is n plus 4 factorial. Okay, let's take a look at F. I apologize. Kind of made a little bit of a spacing error here. Well, this part of the question is again like the doorman, sitting out in front, just like the n+4, just like the 2. Kind of weird though. I don't really like it because it's a trinomial. So let me think about it. Could I factor that? What two numbers multiply to 12 and add or subtract to 7? What two numbers multiply to 12 and add or subtract to 7? Actually, add or subtract to -7. -3 and -4. -3 times -4 gives me 12. -3 minus 4 gives me -7. So I've factored the question so that now I've got a binomial, and then my factorial. So I still have the doorman. It's almost like you have two doormen for this question. You've got x minus 3 and x minus 4 are the doormen. And then the factorial is going to be applied to the x minus 5. So hold on. This is one I think is probably going to go off my page, guys. This one is definitely going to go off. So let's think about this. N minus 1, n minus 2, n minus 3, ... 3, 2, 1. Now, I'm wondering, as I'm cleaning up the brackets that need some cleanup, I'm wondering if there's anybody out there actually seeing a pattern to what I've been doing. -3, -4, -5, -6, -7, -8. I think it would be -9, -10, and so on. So again, very similar to example E, in the sense of I could simplify this question, and instead of writing all of the stuff that I've written previously, I can just write x minus 3 factorial. That's the simplified answer. Okay, let's take a look at G. Okay, I think you've got the idea of the doorman. And again, our doorman looks like it can be factored. It's not a trinomial, but what could be factored is I could maybe common factor out an m. I'd be left with m plus 1. So that's just the green part. I'm just factoring out of the green part. That's like the doorman. Actually, again, two doormen. And that factorial is now going to apply to just the m minus 1. So very, very similar to what I did in E. Very, very similar to what I did in F. I just used common factoring. Okay, so let's leave the doorman where they are. And let's do our factorial. N minus 1, n minus 2, n minus 3, ... 3, 2, 1. Cleanup time. Minus 2, minus 3, minus 4, ... 3, 2, 1. Okay, now when I look at this particular answer, it doesn't look as neat and tidy as my previous ones. 4, 3, 2, 1, 0, -3, -4, -5, -6, -7, -8. This doesn't look like that. It's going 0, 1, -1, -2, -3, -4. This part looks great, but this is messing me up. Could I switch the order? Watch what I mean. M plus 1, M, so I just switched their order. M minus 1, M minus 2, M minus 3, M minus 4, ... 3, 2, 1. Now, does that work a little bit nicer? +1, nothing. -1, -2, -3, -4. Am I decreasing by 1 in each of the brackets? Just like 4, 3, 2, 1. 1, nothing, -1, -2, -3, -4. Yes, I am. So my simplified answer for this particular factorial is m plus 1 factorial. Beautiful. Again, guys, these are going to take some practice. You might need to watch the video a second time, so that you can go over it again. They do take a little bit of practice. This is the first time for you doing this. Okay, let's take a second, make sure everybody's got everything filled out. Okay, you're filling out your note. And then let's scoot to example 5. Now, the instructions for example 5 are completely different than example 4. Example 5 says solve, which means get me an answer. And notice the questions actually look different as well, because the questions actually have an equal sign, a left side and a right side. So what you're looking for at the end for each of these, you're going to have n equal to something. I don't know what yet. I don't have a clue just yet. But you're going to have n equal. Okay, let me show you how to attack them. First thing that I would do is I'm going to write down the equals, and I'm going to write down the 6 on the right-hand side, because there's really nothing for me to play around with or clean up on the right-hand side. Now I'm going to move to the left-hand side, and I'm going to do the same thing that I did in example 4 with the simplifying of a factorial that is a fraction. There's going to be some canceling, there's going to be some matchy-matchy, so hopefully things will go well. Okay, let's take a look at the numerator. N factorial is our basic rule. So notice I just wrote n minus 1, n minus 2, n minus 3, ... 3, 2, 1. Now, the bottom, as we discovered in example 4, there's a heck of a lot of cleanup that's required. But what we also discovered in example 4, and if I can flip back just for a second, is that notice when we look at all of these questions in example 4, what you're left with after the cleanup is just one less in each of the brackets. So n minus 2, n minus 3, n minus 4, n minus 5. So hold on, let me show you a quickie way now that we know how to do these. N minus 2 is your n. Your next bracket should have one less, one less, one less. And that's the 2 steps, the simplification, all in one. Now, do me a favor. Look for the matchy-matchy. Where does the matchy-matchy start? Where does the repetitive pattern start in the numerator that matches with where the repetitive pattern starts in the denominator? I see it. It starts right here. So that means that I can cancel everything from n minus 2, which will allow me to just have the n minus 1 left. Notice the fraction's gone now too. Okay, so at this point, you're going to step back to grade 10 academic, because all that needs to happen now is I'm going to rainbow. I'm going to bring the 6 over, and I'm going to solve a quadratic equation. And you did this in grade 10. What 2 numbers multiply to negative 6 and add or subtract to negative 1? What 2 numbers multiply to negative 6 and add to negative 1? Negative 3 and 2 multiply to negative 6. Negative 3 plus 2 gives me my negative 1. Okay, now hold on. Sorry, I'm going to have to white this out. I'm going to now take each of these brackets, equate them to 0, and solve. And you're thinking, geez, Ms. Martel, are there 2 answers to this question? Algebraically, yes, there's 2 answers. But with factorials, no, only one of them's right. Why? This one right here is a no-go. And it's because you can't take a negative factorial. So if I went to put and try to check and substitute in negative 2 right up at the top, and you can try it on your calculator, you can't have a negative factorial. So this option right here is inadmissible. And we're identifying that by putting the x through it. Yes, it's algebraically an option, but with the factorials, it's completely inadmissible. Okay, let's try another one. I'm going to wipe this out here. Let's try another one. All right, on the right-hand side, I'm going to put the 20. On the left-hand side, I'm going to clean things up. Well, n factorial, I know that that's n minus 1, n minus 2, n minus 3, ... 3, 2, 1. The bottom is the n minus 2 factorial. And again, I know if I clean that up, it's going to be n minus 1, n minus 2, n minus 3, ... 3, 2, 1. So I've simplified, I've got everything nice and tidy. Now I'm going to ask you, where does the matchy-matchy begin? Well, again, the matchy-matchy begins at n minus 2. That's where the repetitive pattern is. So I'm going to be left with n bracket n minus 1 equal to 20. I'm going to expand, just like I did in the previous example, and I'm going to bring the 20 over the equals, and it's going to become negative 20. And now I'm going to ask myself, okay, so it's time to solve a quadratic equation, just like in grade 10. What 2 numbers multiply to negative 20 and add or subtract to negative 1? Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. Okay, I'm going to continue the solving process by setting each bracket equal to 0 and isolating my n. Again, one of my values turns into an n minus 4. I can't have that though, because if I tried to sub it in up here and check it, I can't have a negative factorial. So I'm going to put a big X through it, inadmissible. Okay, we're getting there, guys. We're getting there. We're getting there completely. Let's take a look at C now. I'm sure you're looking at C and thinking, oh my goodness, it's crazy. It is kind of a little bit crazy, but we're going to do it. We're going to go slowly, and we're going to do it together. So what I'd like you to do, just so that we can keep the note nice and neat, can you put your equals right in the middle of the page? Big division, big division. Okay? The 3 is just like that doorman, right? So I'm going to put the 3 where it should go, and now I'm going to just deal with the n factorial. n minus 1, n minus 2, n minus 3, ... 3, 2, 1. Okay. n minus 1, n minus 2, n minus 3, ... 3, 2, 1. I'll do the matchy-matchy after. Okay. Let's deal with the right side now. n minus 1, n minus 2, n minus 3, ... 3, 2, 1. n minus 1, n minus 2, n minus 3, ... 3, 2, 1. So all I've done so far is I've just completely expanded my factorials, and now I'm looking for the matchy-matchy. So let's start on the left-hand side. Let's not even focus our eyes on the right. Is there anybody out there saying, Miss Martel, I don't see matchy-matchy, I don't see a starting point? You don't see a starting point, I agree, because in the numerator, if I would have went one more iteration, okay, every time you do a little bracket, it's called an iteration. If I would have went one more iteration, I would have jotted down n minus 4. Uh-oh, I see it. The next one would have been n minus 5. The next one would have been n minus 6. So where does the matchy-matchy start? N minus 4, both top and bottom. So I'm left with 3n, n minus 1, n minus 2, n minus 3 on the left. Now, let's use that same logic for the right-hand side. If you're saying, geez, Miss Martel, I don't see an n minus 4 on the bottom. Of course you don't. But if I would have went to the next iteration, n minus 5, I still don't see matchy-matchy. If I would have went to the next iteration, I'm starting to see it. N minus 6, n minus 7. So where does the matchy-matchy start? It starts at n minus 6. So what I'm left with is the n minus 1, the n minus 2, the n minus 3, the n minus 4, and the n minus 5. Wow. Now what do I do? The other ones worked out so nice. I just, expanded. They were a quadratic. I was able to factor them. Well, I'm going to want you to put this very loud and proud in your note. Do not expand. These are too big to expand, guys. These are too big to expand. If you started expanding, you would have a quartic, right? N times n is n squared, times n is n cubed, times n is n to the 4. And you'd have a quintic on the right. N squared, n cubed, n to the 4, n to the 5. You don't want that. But can I ask you to do something for me? Put your eyes on the center of the equation, on the equals. Look to the right, look to the left, and tell me if you notice anything that's matchy-matchy. Tell me if you see anything that is identical on the left that it's on the right. I do. Matchy-matchy. So what am I left with? Okay, this is looking a little bit nicer. I can FOIL on the right-hand side. Just cleaning up. Oops, my mistake. Sorry guys, that should be 9n. Bring the 3n over. And now I'm going to ask myself, what two numbers multiply to 20, add or subtract to negative 12? Negative 10 and negative 2? Negative 10 and negative 2? So if I solve this out, oh wow, not one of my solutions is negative. Does that mean that there's two solutions? I don't know. Let me pretend and go right back up here to the top. 10 factorial will work in the numerator, and so will 2. 10 minus 4 is 6 factorial. That works perfect. Oh, wow, wait a minute. 2 minus 4. If I was testing out 2 minus 4, that gives me 2 minus 4 gives me negative 2 factorial. Uh-oh. Inadmiss. So let's be clear on that, guys. If I substitute 10 factorial gives me a result. 10 minus 4 gives me 6 factorial. 10 minus 1 gives me 9. 10 minus 6 gives me 4. Works out perfectly. If I sub in 2 factorial is okay, but 2 minus 4 gives me a negative factorial. 2 minus 6 again gives me a negative factorial. So n minus 2 is an inadmissible solution. I know this was a long one, guys. Take your time. You might have to watch it over again and see, how you fare on the homework. I'm going to post full solutions as well for the homework. Thank you.